These are the notes for the second day, PowerPoint B, for Chapter 18 in acids and bases. First item of business, we're going to talk about water because water is kind of central to this chapter. You notice that I have the self-ionization equation for water, and that's HOH, which is the way we're going to draw water in this chapter. We're going to write it HOH, even though it's H2O, same difference. Splits into H plus and OH minus. And that's why we write it as HOH, because you can kind of split right down the middle here, and the H is H plus OH minus. That leads us to the fact that because it's H and OH splitting from the original water, H and OH are always equal in water. Now that's if it splits in water and we don't add something to it. That leads to the constant, which is Kw, called the ion product constant for water. That's equal to the H plus times the OH. You know as well as I do that when you multiply numbers with exponents, you add those. Well, it happens that when water splits on its own, it makes 10 to the negative 7th H pluses, 10 to the negative 7th OH, and that leads us to the Kw value, which is 1 times 10 to the negative 14th molarity squared. So, and that on this on the little video here, that didn't go to the power. So you need to see that that's 10 to the negative 14th, and then it's molarity squared, the units. That leads us to be able to solve for a problem where they give you the H plus and they want the OH, or they give you the OH and want the H plus. So the way we would solve that would be to write this equation and plug in for the one we have and divide by that one and solve for the other one. So let's say that we're given a problem and they tell us that our OH minus is equal to 2 times 10 to the negative 8th molarity. And we're trying to find out what is the H plus. Okay, so we would use this equation, and it's the equation right up here, the one that says Kw equals H times OH. Remember that the brackets mean mole per liter, equal to 1 times 10 to the negative 14th molarity squared. So now we're going to write the equation. So we have 1 times 10 to the negative 14th molarity squared. We know the OH, so we're going to divide both sides by that. 2 times 10 to the negative 8th, and that is going to equal, when we solve for that, that's going to equal the H plus concentration. So we plug that into the calculator, and remember the way you plug that in on my calculators, you either have an EE key up there in the middle on the TIs, or you have a EXP down on the bottom middle on the Casios. So it would be 1 EE to the 14th, and then hit the plus minus, divided by 2 EE to the 8th, and hit the plus minus, equal, and we get 5 times 10 to the negative 7th. So the H plus is equal to 5, 1 significant digit, times 10 to the negative 7th, and that's molarity. Okay, so anytime you're going from H to OH or OH to H, that's your equation. You'll be given that in the possibly useful page. Remember that you'll be writing the self-ionization of water. It'll probably be on your short answer on your test. Make sure that you know what that equation is. This first one up here. How water splits. That's the self-ionization. So next we move on to pH and POH. pH scale was invented by Soren Sorensen, and he basically was trying to help out some winemakers, and it was a lot easier way for them to understand how to deal with H plus concentrations, because they couldn't do the negative exponents of 10. So what he did is, for instance, if we had something that was an H plus equal to 1 times 10 to the negative 6th, he would just circle the power by itself, and when he circled the power, that is the pH. Power of 10 of hydrogen is what pH means. When the mantissa is 1, you can just circle the power and you're done. When it's not 1, then we're going to have to go up here to our equation, and we're going to have to plug in the H plus and hit the log key, and then take the negative of that answer, because the answer you're going to get is negative. Remember, he left out the negative on his pH scale. That's why we have to come back and make it a negative at the end, because he left that off. So on your calculator, up at the top line, up there, you should see the log key. You'll just enter the H plus, hit the log key, and the plus minus, and that gives you pH. Same thing for POH, which is the power of 10 of hydroxide. We would enter the OH concentration, hit the log key, and then the plus minus. And you don't really have to hit the plus minus. You could just in your mind say, oh, I know that that negative is not really there. It should be a positive. So example 2 in practice problem, page 653, would be good for you to work. I would get familiar with the calculator and make sure that you know that the log key is up the very top, LOG, and then second log is what we're going to be using on the next page when we go back the other direction from pH to H plus. So here's a good example problem just to practice with your calculator. The H plus is equal to 2.0 times 10 to the negative 6 molarity. We plug that H plus in, and on my calculators, the Casio and the TI 30XA, you start on the right, 2.0 EXP 6, and then plus minus. Hit the log, and then the plus minus. You get 5.7 for your pH. Try that out. Make sure you're good to go on the calculator for that. Same process is involved doing the POH, except when you're through, one, you plug in OH, and when you're through, you have POH instead of pH. And remember that pH plus POH equals 14. So, for instance, if you knew that this was 0, pH was 0, then POH would be 14. If this was 7, then the POH would be 7. They add up to 14 total. So you can also go the opposite direction and start with pH and solve for H plus. The formula for that is up at the top of this screen. Negative of the pH. Now remember, it's the negative of the pH because when Sorensen decided to use pH, he circled just the number, not the negative exponent. So you have to put that negative back in or you're not going to get the right answer. And it's the inverse log, and you know, the symbol there, log to the -1, represents inverse, but it's 10 to the x is the best symbol for that. 10 to the x means inverse log, and that's what's on your calculator. If you hit shift log or second log, that would be that inverse log. And that will give you the H plus concentration. Whatever significant digits you start with, that's what you end up with. There's example problem 4 and some practice problems on page 655. And you also have a practice problem down here on the bottom. Once you have the H plus, you could then solve for Ka, or you could also solve for OH, and that's what we've done down here at the bottom. So here's our problem down at the bottom, and it says that we've got a pH of 12.5. What is the OH negative concentration? Remember, the brackets mean mole per liter. So we start out with our raw equation. We're going to take the 12.5, plug it in for pH, put a minus in front of it, and then hit second log or shift log. So all of these equations, the ones on the previous page and this one, you start on the right and work to the left, and then you get your answer. Put in 12.5, plus minus, shift log, and when we do that, we get 3.16 times 10 to the negative 13th. That's the H plus. If we wanted OH, which is what the question asked, what's the OH, then we just divide the KW by the H, and we get the OH. And the answer to that would be 3.16 times 10 to the negative second. Just so happened for this number that 3.16 is the same. It's not always going to be that way. So we'll finish up talking about indicators. Indicators are substances that can change color in the presence of acids or bases. And in the lab that we did with pH, we used indicators. In the lab that we did with the vinegar or vinegar titration, if you haven't done it, we'll be using the indicator there. The indicator told us when we went past the neutral, and that was the neutralization point. Gave you a handout that be good to keep because it has most of the common indicators and the colors that they change when they the colors that they indicate when they change pH. So this finishes up this middle section, and have one section left with 18-4, which would be on the PowerPoint C notes. Good luck.